Now let's take a look at the example of payback period method. So when should we use the payback period method? Payback period is used when you already have a project with a given initial investment P, and also the annual income. You can treat this as the net profit, which is the term A. We also have the interest rate, but now we need to try to solve for N, the number of years you have to run the project in order to obtain the desired rate of return or interest rate given the initial investment and annual income. This is the example. The initial investment for a project is $20 million and a net annual profit is $5 million with the desired rate of return 15%. This is the you can also treat this as the interest rate. What is the payback period for this project? Again, we have to use time value of money, and looks like we've got P and also we've got A. Looks like we can use the equation either P given A or A given P. Either way should be fine, but for our problem I'm just going to use the P given A. I'm going to write the formula here. P equals A 1 plus I to the nth minus 1 I 1 plus I to the nth. Now we just need to plug in the number and try to solve for N. I'm going to calculate the entire process manually. $20 million, that's our present. The annual net profit is $5 million, and then the interest rate is 15%. I'm going to plug in right into this portion directly. So this is going to be 1.15 to the nth minus 1, and this is a 0.15, and this is 1.15 to the nth. All right, now let's solve for this equation. And first I'm going to divide both sides of the equation by 5 million. So this is going to be canceled out. All right, so divided by 5. And then the left side of the equation is going to be 4. I'm going to left out the million and also the dollar sign. And then this is a 1.15 to the nth minus 1.15 to the nth. Next, on both sides of the equation I'm going to time 0.15, so this will be canceled out, and this side is going to be 4 times 0.15, 4 times 0.15, and then right side of the equation 1.15 to the nth minus 1 and 1.15 to the nth. And then we can rewrite this side of the equation as follows. 0.6 equals this divided by this is going to be 1 minus 1 over 1.15 to the nth. And we can move this to the left side of the equation, move this to the right side of the equation, and we can get 1.15 to the nth equals 0.4. And then 1.15 to the nth equals 2.5. All right, now we can take log on both sides. If we take log, the n is going to be descending down, and this is going to be log 1.15, and this is the log 2.5, and then n equals log 2.5 divided by log 1.15. This is approximately 6.6 years. This is saying that given the annual income, initial investment, and the desired rate of return, I have to operate this project for 6.6 years in order to come up with this rate of return. That's payback period.